fundamental concepts of OCI logging service. Log group is one of the core components in the service. A log group represents a collection of logs stored in a compartment. You can simply relate a log group like a folder storing multiple logs. You would always need to create or choose a log group when you're enabling log for a resource. So log groups are defined as a logical container for logs. One of the use case here is you can segregate logs within this log group based on different purpose. As an example, you can group all the write operations of the object storage bucket into one log group and all the read operations into another log group. And in this way, you can quickly navigate into the log data that you are searching for. Logs and log groups are searchable, actionable, and transportable. That means you can search within log groups that have multiple logs, and you can create actions for those search criteria. You can also move log groups. Let's say you want to move from one compartment to another compartment. All the logs and that log group would move into the new compartment. The next purpose of using log groups is that you can limit access into sensitive logs by enabling IAM policies. And that means you don't have to create complex compartment hierarchies to secure your log information. Let's take an example here. And usually there is a default log group in a compartment where you're going to store logs for the entire tenancy. You would then grant access to the compartment for all log administrators using IAM policies. But let's say some logs contain personally identifiable information or PII, and those logs needs to be accessed only by a selective group of log administrators. So by using log groups, you can put those sensitive logs into a separate log group and use IAM policy to restrict access and give access to only a few log administrators. Let's now learn some of the core concepts of OCI logging service. OCI services gives you different log categories for different types of logs. The load balancer service gives you log categories like the access log and the error log. The object storage is another example. It gives you two different categories like the read access events and then the write access events for storage buckets. OCI Connector Hub is a feature that moves logging data into other services of OCI. For example, if you would like to set up an alarm for a specific error log pattern, you can create a search condition for that pattern and then use the Connector Hub to move data into the monitoring service. There are a wide range of use cases for connectors. You can send log data into databases or archive log data into object storage and so on. We'll look into some of these scenarios in a later lesson. The Unified Monitoring Agent is also known as the Fluentd agent, and it is a fully managed agent on OCI instances. This agent is used to ingest custom logs from your applications running on OCI instances. And this agent can also be installed manually on external systems to collect custom logs into the OCI logging service. Agent configuration is a section of logging service where you can provide the configuration for this unified monitoring agent. This configuration is where you define how the custom log should be ingested into the logging service. The audit section of logging service is where you would locate audit events that provides the recorded API calls executed to OCI public API endpoints. So to wrap up, we learned the concept of using log groups. We went through the concept of service log categories, the connector hub for log transitions, unified monitoring agent required for custom log ingestion, and then concluding with the audit section to see the audit log events. And that's all in this lesson. Thank you for watching. Welcome back. We will now focus on enabling service logs. Let's start with the format and structure of a service log. One of the key benefits of using open standards is that every log line is normalized into a common event format based on JSON, and that makes it easy for correlations between logs and resources. Now, this is an example of a DevOps deployment log. A log line has got three key sections: a unified envelope, the Oracle-specific metadata, and the data section with contents of the log line. The unified envelope contains standard information like the spec version, that is the version of CNCF Cloud Event Specification. The type shows the log category, and here in this example, the type is a DevOps deployment. The source is the name of the resource that generated the message, and for example, it is a DevOps project here. ID is a unique identifier for this log message, and time is the timestamp where the message was generated. The Oracle section gives you Oracle-specific metadata. The log ID is the OCID of the log that contains this log message. Log group ID is the OCID of the log group. Tenant ID is the tenant OCID who owns the log object. And compartment ID is the compartment where the log was residing when it was ingested. The data section is the most important part of the log. This would give more specific details on what triggered the log and including other attributes of that event. Here in this example, the log category was for a DevOps deployment, and so it would have the deployment's unique OCID. Each deployment is part of a deployment pipeline, so it will also have a pipeline ID. Then we have the deployment stage ID. The message provides the message body of the event, and here the message is generated for a manual approval stage that is waiting for an approval. The producer is the OCI service that created the specific log message. Object storage is another service that we could reference to service logs. Log resources are object storage buckets. The logs are collected for those buckets. There are two categories here. Write access events are those logs with changes written into the bucket. An example, you have uploaded a set of files into that bucket. Read access events are those logs when you read the bucket. The request action is a key value pair in the data section, and it tells you what type of action was executed. We refer to this field as data.requestAction, and if it is a write access event, this will have values for put or post or delete. Data.requestAction for a read access log would have values of get or list or head. There are more details in the data section of this log, and you can use all of these information in the search criteria. You can filter by name of the bucket, the client IP address, the message body of the log, and in this case, it is a file has been uploaded. The request action is put, and the status code is 200, that is referring to a successful upload. Load balancer is another example of a service log. A load balancer would provide automated traffic distribution from one entry point to multiple servers. There are two log categories for load balancer. The access logs captures information about the request sent to the load balancer. And here in this example, the timestamp is when the request was received, the client and intermediate HTTP proxy IP addresses, and then the time taken at the load balancer and the backend to process the request. The second category is the error log. The error log gives you detailed information for monitoring and troubleshooting. Each error log entry will have information like the time when the request was received, the error type, and any additional details related to the specific error. Here is an example of the data section in an error log. The type is a health checker, and it is a test that checks the availability of backend servers. You can see the error details with health status changing from healthy to unhealthy, the backend server IP address and the HTTP port, the total number of failures, and the log message body with saying the connection has timed out. VCN flow log is a critical service log, and that is used for security, monitoring, and troubleshooting your network. The log resource here is the VCN subnet, and that means you're enabling logging on the given subnet. The VCN log records contain accept and reject records. It gives you details about traffic flow in and out of your VNICs that are attached to your instances. And this would help you to troubleshoot if there are any connectivity problems. The OCI networking service use security rules that can be created using security list or network security groups. It determines what type of traffic should be allowed through the VNIC. So the VCN flow log would also give such details on traffic that is accepted or rejected based on these security rules. You are enabling flow logs at the subnet level. That means you are collecting logs for those existing VNICs and also future VNICs configured to that subnet. And here is an example of the VCN flow log. You can find a TCP request from the source IP address to the destination has been rejected. You can search for the field data.action with providing a string reject that will return all similar requests that are being rejected. To wrap up, we learned the structure of a service log, the unified envelope, Oracle-specific metadata, and the data section. We also referred to a few examples of load balancer service logs, object storage, and the VCN flow logs. So that concludes this lesson. Thank you for watching. Welcome back to this demo. We're going to look at service logs, one of the log category of OCI logging service, and create a few queries to explore this log. So first of all, let's navigate into the OCI console and choose the region and click on top left burger icon, observability and management, and click on logging. The left panel section shows you different options where you can click on the search, which will take you to the search UI. And this is the main page where you would create queries or with search filters. There are two modes here. One is the basic mode, more sort of graphical UI driven, and then you can navigate into the advanced mode. We will get back to this page once we enable a few service logs. You also have the option to save search, where you can see all the saved searches in this section. There are two types of logs that you can configure from this UI. One is the custom log, and the second one is service logs. We will come back to this page in just a moment. The next section is log groups. Log groups are logical containers for your logs. So when you enable a service log, you would need to create or choose a log group. The agent configurations are required for enabling or ingesting custom logs. Service connectors are used to transition or transfer data from a source service to a destination OCI service. The audit section gives you access to all the audit events. So let's navigate back to the log groups, which is the starting point of enabling a log, and create a few log groups. So click on create log group. We are going to create two different log groups. One is for our object storage and another one for VCN. So let's create one for object storage. We will name it as OS for object storage. We will leave all the rest of configuration with default, and let's click on create. We haven't configured any log sources yet, so that's why you can see there are no log sources found to be read. We will create one more log group, and that's for our VCN. So navigating back to the log group page, let's create one for VCN. We have now created both the log groups. We can enable logs from this log section under resources, or let's navigate back to the log section of the main UI and click on enable service log. Select a service which is a virtual cloud network subnets. Resource would be the subnets that you have in that virtual cloud network. So I've got one subnet in that VCN. The log category is for flow logs, all records. We're going to name as flow log. Under the advanced section, you have the option to choose which compartment you want to collect this log and the log group. So making sure you are using the log group for VCN. The log retention is by default, it is 1 month, and you can configure to choose to a maximum of 6 months. Let's go with the default value. Tagging is also an optional component. Let's not use the tagging for now. And let's proceed to click on enable log. The status of that log is active now. You could also see the log status with accessing the service. So let's navigate into the networking service and have a look at this configuration through the service level. And under that subnet on the left hand side, under resources, you can see logs. So click on logs. And we can see the flow logs have been enabled and the status is active. The log name that we created, which is flow log, the log group created for this for the VCN flow logs, which is log group VCN, and it has been enabled.
And that concludes this demo on how to enable the VCN service logs. These logs that we enabled can be filtered using the search UI of the OCI logging service, and we'll be seeing that in one of our upcoming demo. And that's all in here. Let's move on to our next lesson. Hello and welcome to this lesson. We are going to learn about custom logs, which is another category of logs in the OCI logging service. Custom logs are ingested from custom applications running on OCI compute instances, or even logs from an external environment like those workloads running in on-premises environment. In our previous lesson, we saw there are two ways you can ingest custom logs. Number one is using an API called put logs. The second method is using the unified monitoring agent that is also referred as the Fluentd agent, and we will be focusing more on this Fluentd agent in this lesson. The unified monitoring agent is based on Fluentd that used the CNCF specification version 1. It is an open source data collector that provides a unified logging layer between the data source and backend systems. There are different ways you can deploy this agent. The agent can be enabled through the Oracle Cloud Agent plugin UI. The Oracle Cloud Agent UI is where you can manage all the software plugins for the instance. Within this plugin UI, the agent is called Custom Logs Monitoring Plugin. Now, the plugin support would also depend on the compute shape that is being used. For any instances using ARM-based Ampere A1 compute shapes, the Custom Logs Monitoring plugin is not supported. The second way to deploy the agent is to install the agent manually on the instance. This method is highly used for instances that are not supported with the plugin, or it could be systems running in an external environment. There are different operating systems supported. You can install the agent on Oracle Linux version 7 or 8, CentOS versions 7 or 8, Ubuntu versions, and also various Windows Server versions. Let's look into the workflow of this agent. Enabling custom logs is a two-step process. The first step is that you can see in the source environment, you would need to install the agent or enable the agent plugin on those instances from where you want to collect the logs. This agent is responsible to fetch the log data as instructed by the agent configuration. The second step is the agent configuration that you create within the OCI logging service. Within this configuration, you would specify which host or instances you wanted to collect the logs, what specific logs you should collect, like the syslogs or application level logs, and then you could add parsers into this configuration. Log parsing is a method to split large volumes of logs and making it easy to interpret and analyze the data. For example, you can choose parsers for XML or syslog or JSON types. And the last step is to define the log destination that will include which compartment where you want to store the log, a log group, and a specific log object for storing these custom logs. Let's look into the agent configuration, and this is one of the configuration steps to specify which instances you wanted to collect the logs from. This can be done through a section called host groups. If the source environment is a set of compute instances, you could choose a dynamic group that defines the list of instances where you wanted to collect the logs. You would also need to create an IAM policy for this dynamic group, and here is an example to show the syntax of this policy. Allow dynamic group with the name of the group to use log content in tenancy. The dynamic group would contain a rule that defines the host with specifying multiple instances OCIDs or compartments OCIDs. The next component in an agent configuration is that it allows you to select the type of logs you want to ingest. There are different supported log inputs. You can choose a Windows event log that will have event channels for applications, systems, or security. Or you can choose a log directory path where you can specify the path of the log file. Usually a path is specified for Linux systems, and as an example, the /var log messages log file. We spoke about parsers. There are advanced parsers you can choose. You have the options to select parsers like Audit or JSON, CSV, syslog to parse the data in the chosen format. Log destination would define which compartment to store the logs, the name of the log group, and the log object for those custom logs. To summarize, we learned the different steps involved in enabling custom logs, the unified monitoring agent based on Fluentd, and that is also referred as custom logs monitoring plugin in the Oracle Cloud Agent plugin UI. And then we looked into the agent configuration specific, the dynamic groups, the different types of parsers that we could use. So that's all in here. Thank you for watching.
Welcome back to this demo. We're going to look at how to configure custom logs with OCI logging service. Creating a custom log is a two-step process. You would need to create a custom log object first, and then second, create an associated agent configuration for that object. In this demo, we will be looking at enabling custom logs for an instance, and logging provide an easy mechanism to enable and manage the agent for a set of supported operating systems. You can enable the agent directly when creating the instance. So first of all, let's navigate to one of the instance and check the custom monitoring plugin status. I am using an Oracle Linux instance with the host name CLI, and we will be using /var log message as the custom log to collect. Click on the instance and then on the Oracle Cloud Agent tab. You can see the custom logs monitoring agent is enabled and it is running. We will now create a dynamic group for this instance
which we require with the agent configuration. We will use the instance ID and the value of the instance OCID. You can also add multiple instance ID to collect custom logs from those instances. We will use only one for the CLI instance, and so let's proceed to create. We are now ready to create the custom log and its agent configuration. So let's navigate back to the logging service. Click on Create Custom Log. Provide a custom log name. Choose the compartment and then the log group. And then click on Create Custom Log. The next step is the agent configuration. You can choose to create the agent configuration now or add the configuration later. Let's create the configuration with providing a configuration name. Choose the compartment and choose dynamic groups under host groups and then the dynamic group that we created previously. You have the option to create policies for the instance in the dynamic group to use the logging service. So let's proceed and click on Create. Under the agent configuration, we will need to specify the log that we are going to collect along with the log file path. We are using an Oracle Linux instance, so we would use the input type as the log path. We will specify a name as messages. And in this example, we will use the var log messages as the log file. You also have advanced parser options which you can choose to parse the log in the chosen format. For example, you can choose a CSV or a syslog or JSON format. We are not going to use advanced parser options for now. Verify the log destination with the right compartment, the log group, and the log name. And click on Create Custom Log. You can see the log that we created under the specified log group. So let's go into the log group and click on Demo Log Group and click on Logs. You can see I have my CLI instance log, which is a custom log type, and the status is active. It will take a few minutes to start ingesting the logs, which we can see on the Log Explorer Search UI. I have now navigated into the Log Search UI, and let's try to create a search criteria and look for the specific logs from the CLI instance. Click on the field Select Logs to Search. We will look for the compartment. The compartment is my demo. We will select the compartment, but let's not add the compartment into the search, which will also add the service logs into the search. So we will remove the compartment. And in the compartment, there are a few log groups. So we will select the demo log group. We will not add the log group into the search criteria. In the logs, we are looking at my CLI instance log, which we will add into the search. And click on Continue. The logs are now populated. We can now expand each log entry to view the details. The log details have the specific log message, the compartment ID, the ingested time, the instance ID, log group, log ID, the source, which is the CLI, the subject, the log file path, and then the type of the log, which is the custom log. The before and after view shows the log entries that were reported before and after this log message, and it makes it easy to troubleshoot, to look into the traces, what happened before and after the log message. We could also refer to custom filters, and with choosing data.message, you can see the list of all messages that are collected, and you can filter based on your search requirements. You can also save the search or create a service connector to transition the logs into other OCI services like the monitoring service, logging analytics, etc. So that's all in this lecture. Thank you for watching.
Welcome back. This lesson will focus on getting access into the OCI logging service using IAM policies and some of the different ways to search and explore logs using the OCI console. So first of all, IAM policies are used to grant or restrict access into the OCI logging service, and it is defined based on your requirements. A simple way of choosing the access level could be, you could have two categories of user groups. One would be log administrators who can decide on which logs are to be enabled, what log groups are to be managed, and so on. The second type of role could be log viewers who could just have read permissions to search and view logs. So here we are listing IAM policies that you may use for a few user groups called log admins. The first level of access is to inspect, and the policy would look like allow group log admins A to inspect log groups in compartment XYZ. This would allow the log admin group to view the log groups in XYZ compartment. The second level permission is the read level. Allow group log admins B to read log groups in compartment XYZ. And this policy would allow the group to read the metadata of logs or log groups. The third level of access is the use level. Allow group log admin C to use log groups in compartment XYZ. And this would allow the group to update the log groups or logs within that log group. The highest level permission is with the verb manage. So the policy here, allow group log admins D to manage log groups in compartment XYZ. And here the user group log admins D would have all the permissions as compared to other log admins groups. With the manage permission, the users can create, update, or delete log groups and logs that are part of the compartment. The next rule is applied to a group called log viewers. And if you would need to give permission only to search log content, the policy would be allow group log viewers A to read log content in compartment XYZ. Agent configuration is a step involved with custom log ingestion. And to have a group to provision agent configuration, you would use this policy, allow group log admins E to use unified configuration in compartment XYZ. Along with the agent configuration, the compute instances need to have access to get this configuration and push the logs. So you would need a policy with the dynamic group, that includes the instances. And the policy would look like allow dynamic group production fleet, that's the name of the dynamic group, to use log content in compartment XYZ. OCI logging service gives you a powerful search engine tool to filter index logs through the OCI console, CLI, or APIs. You can search logs based on custom queries. There are two modes in the OCI console, the basic mode and the advanced mode. You can create basic queries using the basic mode and create complex queries using the advanced mode. There are multiple filtering options you could add to the search criteria. You can filter values by log fields, or search by a string or a keyword, or filter by time intervals. Each log entry can be explored in detail. You can find these details with expanding the log line section and view the entire payload structure in a JSON format. You can also access the before and after log view that shows the exact proceeding of log entries and also the successive logging lines of the log object. The search results can be exported into a JSON file. The log retention period for service and custom logs is maximum up to 6 months. The log retention for audit logs is different, and we'll cover that in a later lesson. Logging service also provide you features to view the filtered log data. You can visualize data with chart widgets. You can choose the stacked bar chart or a pie chart, donut type, or line chart. And then the log data that is filtered or visualized can be auto-refreshed for every 5 minutes or 15 minutes to view the most recent logs in real time. To wrap up, we learned the IAM policies, some of the IAM policies required to manage and view log groups and logs, the capabilities to explore logs with searching and visualizing logs with using different chart options. So that's all in this lesson. Let's now move on to our next one. Welcome back. Let's now learn about logging query language and see how to write logging queries. You can perform log searches using the basic mode that gives options to filter the log data through a graphical UI. Or you can use the advanced mode where you can create your own custom complex queries using the logging query language. In the logging service, you are provided with features to search multiple logs and data sources across multiple regions. Logs can be filtered using log fields, or you can provide a keyword in the search criteria with choosing a time interval. Apart from using the OCI console, you can also use the API search logs to run a log search. The next way of searching logs is using CLI, or the command line interface. Here is an example on how to use CLI and the syntax. The command is OCI logging search followed by search logs, the parameter search query, and then the actual query with the time start and time end for the query. Here is an example of the command. We have created a search criteria to search logs within the entire tenancy for the given start time and the end time. Logging queries are created and processed based on a data flow model. And what that means, each query can reference one or more logs, and then you can add multiple criteria to filter this data, and it produces the final data set. The logging query language provides you several operators that can be used for searching, filtering, and aggregating both structured and unstructured logs. The query is the most important part while defining a search criteria. We saw the CLI parameter search query and a value in our previous slide, and that is where you specify the query condition. So the logging query can include a few components like log streams, log fields, data types, operators, and expressions. We will look into each of these components in our next set of slides. Log streams are used to define what set of logs that you need to search using the query. And here is a syntax, and to make it clear, we will refer to these few examples. In the first example, you are defining a search criteria within the entire compartment. So you would specify search and followed by the compartment's OCID. In the second example, you are searching within a log group of the compartment. So you would say search followed by compartment's OCID, and then you would use a / followed by the log group's OCID. This entire section would become a log stream. The same way, if you want to search a log object, you would use search compartment OCID / the log group OCID, and then using another / followed followed by the OCID of the log object. You can search multiple compartments or multiple log groups or log objects, and here you would use a comma to separate and define multiple streams. In the example, there are two sections defined. In the first section, you are searching within a log object of a log group in the compartment. And in the second section, we are also adding another log group of another compartment where you want to run this search query. Fields represent specific field in each log line, and it can be used to search within log streams. Fields are also case sensitive. Let's look into a few examples here. If you remember the structure of a service log, there is a unified envelope, the Oracle section, and the data section with some key value pairs. And here in the example, with specifying the type and the value for VCN flow logs data event, this will return all the logs that belongs to this specific type. The same way you could filter data fields. The data section is the most important section in a log, and you can filter like data.action is not equal to accept, and this will show all data actions that are rejected. In the next example, you are looking for data.message with the message body as the condition. Data.resource ID with the resource OCID will show all the logs for that specific resource. Data types are about searching with strings or numbers using arrays, booleans, timestamps, and intervals. You could search with a string. We saw that in our previous slide. We used the string except that was mentioned within a single quotes. The single quotes would take the entire value just as it is. You could also specify wildcards with the asterisk sign to search strings starting with a word or letters. Integers are another data types, and it is usually used to mention timestamps like the start time and the end time. Tabular operators are one of the common operator used in a query. You could use the search operator to construct a log stream. The where operator filters the log stream using scalar operators. We'll be seeing those scalar operators later in this lesson. Top would fetch only a specified number of rows from the log stream. Sort would sort the log stream by columns in ascending or descending order. Dedupe is an operator used for processing the log stream by filtering all duplicates by specified columns. Select would apply a series of named scalar expressions to the log stream. And here are some more examples to help you understand this better. You can search the application object to filter by logs with the level equal to error. The pipe symbol is an expression used between these operators. And in the second example, you are returning the last 3 rows from the search application log stream. And in the next one, you are sorting based on values that are returned. And then in the last one, you are defining with scalar expressions to show the selected fields from the log stream. Now, scalar operators are another type of operators, and it is usually used in calculations or matching conditions or comparing between values. There are arithmetic operators used for addition or multiplying or dividing values. Boolean operators are used with using an AND operator, and it is used for defining multiple conditions together. The OR operator is for matching one of the condition. And then comparison operators are used for comparing values. These are another 2 examples here. The first one is searching all log objects within a compartment, and the log content that contains a specific IP address 10.50.0.220, and finally sorting by date and time in descending order. In the second example, you are searching all logs within a compartment, and you're looking for either of these request actions. One could be delete, or the other could be a put action. And then using Boolean operator AND, you would only want to look into an object storage bucket that is named production bucket, and finally sorting that data by date and time in ascending order. To wrap up, we learned the structure of a logging query, the different components of logging query language, and using some of the data types, operators, and expressions. And that's all in this lesson. Thank you for watching. Hello and welcome to this demo here. We'll be looking at how to enable service logs for an object storage bucket and use logging queries to search and filter these logs.
I have created a bucket here which is named production bucket. I haven't uploaded any files or objects yet into the bucket, but let's have a look at the logs section. There are two categories of logs for object storage buckets. You have the read access events, which is, for example, if you're downloading a file from the bucket, that would be a read access. You also have the second category, which is a write access event. For example, if you're uploading a file into the bucket, that would be a write access event. And for each category, you can enable log, and you can direct each event into a respective log group and also a log. Let's now enable log for both events and then upload a few set of files into the bucket and have a look at those log events using the OCR logging service. The log group has to be the log group we created for object storage. We're going to leave the log name as default, which is the name of the bucket, followed by read. You can give any name, whichever the way that you prefer, but let's leave it the default here. Log retention is going to be 1 month, and click on enable log. The same way we are going to enable write access event. Change the log group to log group for object storage. The log name is default production bucket write. Log retention is 1 month, and click on enable log. The status of both read and write access events are active now. Let's upload a few files into this bucket. The files have been uploaded. We will navigate back to the logging service. The search UI gives you different fields where you can filter and search for the log data that you're looking for. So in the select logs to search field, you can click to choose the right log group and logs. So in this case, let's expand the compartment hierarchy and click on the compartment to show the log group. We will select the log group that we created for object storage. We are not going to add this log group to our search criteria, but we just wanted to see the log objects part of this log group. We will then choose the production bucket write log object and make sure you click on the add icon here. Also note you have to remove this compartment from the search criteria, otherwise you are going to see all the logs which are part of this compartment. So let's remove the compartment from here, and you're now only searching this log object and the logs that are part of this log object. So let's click on continue. We'll have to filter the time by last 15 minutes. So I can see there has been some logs which has been reported. So let's scroll down to see the log. I can see the object have been, there is a log line that says the object have been uploaded. Click on the log line to see the data in a JSON format. There are 3 different sections in a log line. The data section is the most important section in a log. You have multiple key value pairs, and in this case you can see the name of the bucket, which is production bucket, the client IP address, which is the IP address from where the object was uploaded, the compartment ID, the name of the compartment, then you have got the message body where it says the object uploaded. Then you have the object name, the file name, which was uploaded into the bucket. The region, the request action, which is a put action here since we uploaded the file into the bucket. You have also the status code here. 200 means the file was successfully uploaded. And then we have got the Oracle section, the Oracle specific metadata that gives you the compartment OCID, the time when it was ingested, the OCID of log group, the logs OCID, and the tenant ID. Then we have the unified envelope of the log, which has the source referencing to the production bucket, the name of the bucket, the spec version of CNCF. Subject is referring to just the file, just the name of that file, and the type of that event, which is referring to the object storage, put object event type. And one of the purpose of this key value pair is you can use these fields to filter or provide custom filters and look for this specific data. For example, you can filter by object name, which is the name of the file here, or you can just look for the message. Let's say if you want to search for a string or just putting the message body here, you can use these fields to add into custom filters. And to add custom filters, you would use this field here. If you just type in data.the field name, that will look for that specific value for that field and return back the log lines that contains that data field value. And for example, if we choose the data.bucket name using a comparison operator, which is equal to, and you can choose by the production bucket that we named for that bucket. If you put that filter in here, you can see time has been gone, so we'll have to filter again by past 1 hour. You can see the events that are being generated for that specific bucket. You can then toggle the advanced mode if you want to write a bit more complex queries. So you can see the query that we created now. The other way of searching a string in the log content is you can replace the data.bucket name with log content. So let's quickly change the field, the key name here to log content and specifying the value of the string. So I'm going to put the production bucket in single quotes and using a wildcard character, and let's click on search. So before I click on search, I wanted to change this again because the time has passed by. So I'm going to choose for the entire day and click on search. So this is returning me all the events that are containing this particular string, which is production bucket. So the same way you can add multiple strings or any fields that you think that you want to add that as a string and search for the data that you are looking for. So in my case, I have uploaded some objects. I have also deleted some objects. So that's why you're seeing all these log events here. So that's all in a nutshell about logging service and how to enable service logs into OCI's logging service and how to write some basic queries and search for the log data from those ingested logs. So that's all in this demo. Thank you for watching.
Hello and welcome to this lesson on Connector Hub. OCI Connector Hub is a fully managed service that helps you to orchestrate data movement between a source and a destination OCI service. And this is made possible by configuring connectors with a few configuration parameters. The first parameter is called source. This is the service that contains the data that you want to move. For example, logging is a source service because you wanted to move log data from logging to other OCI services. The second parameter is called the target. This is the target, the destination service that receives the data from the source. This target service would also process and store the received data from the source. Then there is a task which is an optional filtering, and that is applied to the data before moving it from the source to the target. As an example, you may prefer to send log data that contains a specific value. You could add multiple filters to this task. Let's look into the workflow of connectors with the logging service. On the left, you have OCI services emitting different types of logs, like the service logs, custom logs, and audit logs. In the next stage, this is where you would search and analyze this log data. Logging service gives you different ways to process this data using OCI console or CLI or APIs. Using logging query language, you can write queries to filter the log data that you're looking for. And the last stage is where you can take actions using the connector hub. You can define to move the log data into different services like the object storage, streaming service, logging analytics, monitoring, Oracle functions, or notifications. There are different use cases you can achieve with using connectors. With the integration of object storage, you can transition log data to be archived into the object storage buckets. You could also emit log metrics into the OCI monitoring service and integrate with dashboards and alarms. Another use case is about automated remediation using Oracle functions and alerting with notification service. Let's say you see an error in your application logs, and to remediate that problem, you may want to spin up a standby instance, and that can be executed using an Oracle function. Another use case could be you may want to set up an alert with emailing users using the notification service. Logging analytics is a service used for advanced log analytics, and you can set up deeper analysis with transferring log data from logging to logging analytics using the connector hub. Connectors could also be used with third-party services. You could leverage the integration with the streaming service or object storage to move data into Kafka-compatible third-party monitoring tools where you can consume this data. To summarize, we looked into the key concepts of Connector Hub, the workflow with logging and connectors together, and to conclude, some of the top use cases of using the service. So that's all of this lesson. Thank you for watching.
Welcome back. We are going to look at service connectors, which is a service used to send data between services of Oracle Cloud Infrastructure. Service connectors can be also accessed through the OCI logging service. So let's navigate to the top left icon, Observability and Management, and under Logging, click on Service Connectors. I haven't created any service connectors yet, so let's proceed to create one. A service connector have got three main concepts. Number one, the source. This is the source service from where you want to send data. For example, we are going to send data from the logging service. Then you have got a task, which is optional. The task is about applying certain filtering conditions, or you could also execute an Oracle function task. And the third concept is a target. A target is the service that is going to consume this data or collect this data. So let's proceed to create a connector. I'm just naming the connector as my connector A. I'm using this connector to send data from logging to monitoring. The resource compartment is my demo, which is where I have created my log groups and log objects. The source service is going to be logging. The target service is going to be monitoring. Under the source section, we need to select the log group. So here we have previously created two log groups. One is for VCN and another one for object storage. So I'm going to select the one for object storage here. There are two log objects that we created. One is for the write access events and another one for read access events. So I'm selecting the production bucket write log object. We are also going to add a log filter task with selecting the data.action field here and choosing an operator, a comparison operator equal to. So here, if you don't find a value, you can just type in a new value here. So there are different request action in a write access event. For example, you can choose the put action for any uploads. So we wanted to send all the upload events into the monitoring service. So let's just type in put. It is a new value. So just click on put a new value here. You have an option to configure additional tasks. For example, you can choose an Oracle function to be executed when the service connector is running. We are not going to select an Oracle function at this stage. So let's proceed to choose the target configuration. I've selected the compartment, the metric namespace here. So again, we need to create a new metric namespace here. So I'm going to choose or provide a name as my custom namespace. And then select here. The metric is also new. So since we are using request action put, we're going to name this metric as uploads. As you enter the metric, you can see there is a requirement to create a policy, an IAM policy, which will be automatically created with clicking on create. So I'm going to click on create here to create that policy. The policy is created. So let's dismiss this notification here. You have options to add dimensions. Let's say if you want to filter by a specific resource ID or a resource name, you can add that. For now, we are not going to choose any dimensions. The advanced option provide you ways to add tags. Again, we are not going to choose any tagging at this stage. So let's proceed to click on create this service connector. So I have now created my first service connector, which is named my connector A. You can see the configuration is I'm going to send data from logging service as the source and to the target monitoring service. So this connector is going to send all the upload events to the monitoring service, and we can access the monitoring dashboards to see if there are any specific events reported. So let's go back to the service connector page and create a few more service connectors. Again, clicking on create service connector. So I'm going to name this as connector B. The source service is again logging. The target service is again monitoring. Under the source, I'm choosing a log group as object storage again. The logs are again production bucket write. And this time, we're going to choose all the delete operations. So let's select the property as request action, choosing the operator equal to. And here we are going to choose the value as delete. You also have option to add additional filters. We are not going to add any additional filters at this stage. Again, configuration task, we are not going to add any task. Under the target configuration, the metric namespace, let's choose a metric namespace here. So one thing which you notice here in our previous connector configuration, we created a metric namespace, but you cannot access that here because the data has not been sent or forwarded yet. So unless and until the monitoring service receive the data, you won't be able to select that metric namespace in a new connector configuration. So we will have to choose another metric namespace in this case. So let's put in another my custom namespace here. I'm naming it as my custom namespace 2. Use the metric as delete. And again, you would need to allow with a IAM policy. So I'm going to create that policy here. And let's proceed to click on create. We have now created our second service connector, my connector B, and we use the same configuration. The source is logging and the target is monitoring, but this connector is going to look for all the delete operations or delete log events with using this connector. We will also create one more connector, and that's for sending data from logging to an object storage. But before that, let's navigate to the object storage section and create an object storage bucket for collecting these logs. So we can see the production bucket here, where which we are going to send logs from this bucket. So let's create a bucket. We will name the bucket as logs. You could either choose a standard storage tier or archive. So let's just choose standard one for now. Encryption is default. We will use the Oracle managed keys. We are not going to add any tagging here. So let's simply click on create. So I've created the object storage bucket called logs, and let's go back to the service connector page. We will now create our third service connector. I'm going to name it as my connector C. We are sending data from logging to object storage. The source service is logging again. The target service is object storage. So the source configuration, we are going to choose again the log group for object storage. And this time we are going to choose the production bucket read. Under the log filter task, we're going to choose a log, a data property here, which is the data.message, and choosing the operator equal to. And these are two different message bodies, which is usually reported in the log event. So when you access these buckets, object storage buckets, you will get a log event saying list of objects retrieved. So we're going to choose this particular log message body. We're not choosing any optional configurational task. And the target, again, choosing the compartment, and then the object storage bucket where we want to send this log. I'm choosing the logs, the bucket that we just created. So let's proceed to click on create. So the configuration is complete. I'm using the logging service as the source and the target as object storage. Looking into the service connector page, we can see all the three different service connectors and the status is active. So let's now navigate to the object storage UI, the production bucket, and upload a few set of files, and also deleting a file from that bucket, and see if we can access those events from the monitoring service. I will upload a few set of files now. the files have been uploaded. I will also try to delete one of this file because we have created a service connector to look for delete events. So I'm going to delete the first file in this bucket. So let's now access the monitoring service and look for the metric namespace that we created. I have accessed the Metrics Explorer UI. So if you scroll down under the query section, you have a metric namespace drop-down, and you could see the two metric namespace that we created. So my custom namespace we created, that's for the uploads. So let's select that. Under the metric name, you can see the name of the metric, which is uploads. Let's leave the interval as 1 minute and statistic as mean. And then click on update chart. You can see that we have initiated the upload during this time range. And the same way, if you choose the metric namespace for delete operation, which was my custom namespace 2, and choosing the metric name delete, let's update the chart again. And we can see the event for which the file was deleted. Let's now navigate into the object storage section and access the buckets that we created for collecting logs. So clicking on logs bucket here, and you can see it has started collecting the log files here, and these are the read events, the read access events when we access the production bucket, and it will generate a log event called listing objects retrieved. So that's the event, or that's the log events that has been collected in this object storage bucket. So that's all in this demo. We created 3 service connectors and transitioning log data into monitoring service and object storage. Thank you for watching.
Welcome back to this lesson on audit logs. Audit logs, which can also be referred as audit service, track all security-related events, and it provides visibility into changes that are occurring to OCI resources. The service automatically records all the REST API calls executed to OCI public API endpoints, and it is stored as audit log events. By default, audit logs are retained for 365 days and it cannot be changed. This retention period is a tenancy level setting. That means it applies to all regions and all compartments. The audit service records REST API calls executed by different sources, the API calls by OCI console, CLI, command line interface, SDKs, or it could be your own custom clients, and also those calls triggered by different services of OCI. The audit log is structured in a way that it makes it easier to understand the event. Each log event contains a header ID, the time at when the API call was recorded, the source of the activity, and also the target resources of the activity, the type of action, for example, whether it is a get or post or delete action. Then there are request parameters, the type of response, and the response parameters. New activities are appended to existing list of audit log events, and it depends on the processing time, which means it can take up to 15 minutes from the time when the API call was executed. There are multiple ways you can access audit logs. You can access these log events using OCI console. It is part of the OCI logging service. Or you could use APIs or using the SDKs for Java. Similar to other log types, audit logs can also be searched and filtered based on your requirements. As an example, you can filter by a user account or filter by the resource. or filter by an API action, filter by time range, or using custom filters. Let's look into some of the use cases of audit logs. This data can be used to perform diagnostics of issues and then correlating those audit trails together. We can track resource usage consumption. Monitoring compliance is one of the top priority in security operations. That means keeping up the business standards and reputations for the organization. Audit logs are widely used to monitor security-related events, like, for example, tracking all the user activities and the actions performed by an API path. You also have the option to display the event in a JSON format. And here is a sample audit log that provides different key value pairs for all the resources. Now, there are some policies, IAM policies, required to view these audit logs. These are two levels of policy permissions. Number one, audit logs at the tenancy level. The policies allow group auditors to read audit events in tenancy. This policy statement gives the specified group called auditors the ability to view all audit events in the tenancy. The second policy statement is for viewing audit logs at the compartment level. Allow group auditors to read audit events in compartment Project A, and that will give the group access to the logs for the specific compartment named Project A. And to wrap up, we learned about audit logs for monitoring REST API actions, the structure of this log event, some of the use cases, and concluding with the IAM policies for viewing audit log events. That's all in this lesson. Thank you for watching.
Welcome back. Let's now look into the audit log category of logging service. So to navigate into the service, let's click on the top left icon, observability and management, and under logging, click on audit. So the audit logs is another log category in logging service, and it gives you a very similar UI what we have seen previously for service logs. But before we get into the search filters, let's take a look into the log section. What are the different fields that represents for each log event? So you can see there is an event time which says when the audit log event was generated. Then you have the user column that shows if which user invoked that API operation. Then you have a resource column, and then the most important column is the action, which shows whether it is a post or get or put action that was executed. Then the next column shows the event type, which event was executed. And then finally, you have the status column here, shows the status code. 200 means it is success, 404 means it's a failure. Right, so that's the quick view on how to access the audit log. And if you want to drill down further into each audit log event, you can click on this icon here, which will take you to the JSON format of that specific event. And the structure is very similar to what we have seen before. You have the low content section here, and underneath you have the data section, which gives you all the specific data about that event. You can see the event name. This is for Exchange Work Submission. Then you can see the message, the data message, which says in this example says the Exchange Work Submission succeeded. Then you have the Oracle section here, which shows the compartment ID, the ingested time, the log group ID, and then the source section giving you the spec version, time, and type, the event type of that log event. So I'm not going to go further into the log, the structure of this log event, because we have covered this part of talking about the log structure in our previous lesson. So that's how you can drill down into specific log. And now going back to the search UI, the search filters, there are different ways you can filter. And again, this is very similar to what we have seen before. You can apply a user filter, or you can apply multiple user filters. If you want to filter by users, you can also apply resources for filtering the data. And then the request action types is basically if you want to filter down by the API operation, whether it is a get, call, post, put, patch, or delete. You can choose an API operation here. Let's select post here, and you can see the UI has been updated with all the post operations executed. Then you have an option to select further filter down with selecting the event type. And in this case, you can see there are two event types here. One is for the Compute API GET instance, and the second one for the Management Agent Exchange Work Submission. You can select whichever event type that you want to filter down. And then you also have the option to provide custom filters. So these custom filters are your the data that you have seen within each log event. Let's say, for example, you want to filter down by data.message, right? So you can just simply type in D, and when you say data, you can see the different fields that are part of the data section. So you can choose data message. You can use the comparison operator is equal to, and then you can, let's say, select the one which we just saw, the exchange work submission succeeded. And that's how you can apply a filter, and choosing a filter by time, whether by past 5 minutes, 15 last hour, or 3 hours, or last 24 hours, or even you can provide a custom filter. So with choosing a filter by time, you can apply the changes, which is automatically shown in the screen. So you can see all the audit log events related to based on that filter. Now you can see there is an option to convert to search. So what this means is, right now you're using the basic mode of the log search. Now clicking on convert to search will take you to the advanced mode, where you can write queries using the logging query language. We have seen how to write logging queries in one of our previous lessons, so I would recommend you to go through that lesson, how to write queries using the logging query language. And also you need to note some of the search queries that you write using the advanced mode may not be supported by the basic mode. So sometimes when you click on the switch to basic mode, you might get a warning or a message saying the query is not supported in basic mode. So if you switch back to the basic mode, whatever query that you have written might be lost. You have the option to save the search before you switch back to the basic mode. Right. So in this case, let's just switch back to basic mode, because we haven't really written any sort of advanced query here. So let's switch back to basic mode here. The activity stream tab here will enable you to see the audit logs as a visual sequential list. You can see by date. You can see by date from newest to the oldest log event. And this is very useful in terms of troubleshooting the sequence of API operations. And you can also look into each individual event and get to know what really happened in that specific time. Now the color representation here tells you whether it was a success or it was a failure. We saw in our previous example, 404 means it was a failure, 200 means it was a success. There are different other status code that you can refer to, so you can make out, looking into the activity stream, which are those operations succeeded and failed. So that's all about audit logs. Thank you for watching.